Good morning, students. Good morning, everybody. Today, let me welcome you all for the session of signal systems subject, that is basics of signals. This is my fourth lecturing sessions. In all my previous three sessions, I talked about signals, basics of signals, types of signals actually, right? And then afterwards, basic operations on signals we discussed. Basic operations on dependent variables we have seen. Today we will see basic operations on independent variable. Independent variable means, let's say y of t is equal to x of t. Yeah, this variables. Right, we have talked about this already. Basic operations on dependent variable. All signals we talked. Amplitude, scaling, additions of two signals, subtractions of two signals, multiplications of two signals, then the integrations of signals, differentiations of signals we have seen for full variable, dependent variable. Now we are talking about independent variable. That is these three properties: time scaling operations, time shifting operations for this. That means x of EAT, that is t is the time scaling factor, right? That is one operations. Then x of time shifting operations, x of t minus 2 or t plus 2, like that, shifting. Then time folding, that is y of t is equal to x of minus t, reflections property. All these three properties will deal today: time scaling operations, time shifting operations, time folding operations. Before this, whoever can study this actually, this is coming under VTU, under module 1 to all of you. Fourth ECE students, especially for the electronic students, but it is not specialized to electronics only. It is any other branch who is having signal systems subjects. For example, electrical, for example, TC, for example, IT. Any other branch who is having basic signal systems, right? They all can study this, right? Whoever interested in BE, ME, PhD, nowadays signal processing is a very popular area where everyone is looking jobs in signal processing only because of mobile. Mobile is the best example, right? Those students, we can all study this, right? Under this subject, I've kept some for 72 to 3 videos. You just go on, go to the YouTube, type Dr.Basavaraju.C, right? Under this, I've kept all these sessions. You all can use it, right? You all can utilize this, right? Now, today, let me go to today's topic is basic operations on independent variable, this variable. Based on that, 3 operations we are discussing: time scaling, time shifting, time folding. Let us see now this. For example, time scaling operations. Very, very simple, interesting. For example, let us say x of t be a continuous time signals. Then y of t is obtained as by scaling the independent variable t, by a factor called a, right? Now scaling factor is a, independent variable is t. Now see, for example, a greater than 0 is the conditions. Based on this value of a, based on this value of the scaling factor, we get 2 types. One is a compressed versions of image, compressed versions of a signal x of t, compressed versions of x of t, and second is expansion versions of x of t. Expansion versions of x of t. One is compressed versions of x of t. Let's say x of t is a waveform. Then compressed versions of x of t. This is what we are using in mobile actually, right? And expansion versions of what is the signal? X of t, expansion versions based on this value. Now let's see those two. For example, let us say those two as two cases. Case 1, if a is greater than 1. Let's say a is greater than 1. And let's say a is equal to 2, for example, x of 2t. Then x of t is a signal. X of t, let's say we have this. Then y of t is obtained as compressed versions of x of t. This is x of t, compressed versions of x of t by a factor 2. 2 times if you compress this, you will get this, exactly half. Now see this is x of t. X of t, see, amplitude I am not discussing. This amplitude y of t is equal to x of t. amplitude. This dependent variable already we checked. We are talking only this time axis. Amplitude must be same. For example, 2 year also, 1 year also, right? Whereas the time axis is compressed by 2. For example, 0 to 1 it is values 2. Here 0 to half is compressed as 2 amplitude. Then 1 to 2 its amplitude is 1 year. Here half to 1 is exactly half compressed by 2 factor. Right? That's what compressed versions of x of t by 2 factor. Right? Don't get confusion. This is a signals compressed by 2 factor. Right? This is one. Similarly, expanded versions of this x of t is nothing but exactly double. Right? Based on a. For example, if a is less than 1, then y of t is obtained as compressed versions of x of t. Now see, expanded versions of x of t. Double. Exactly. For example, now see 0 to 1. 0 to 1 we are whatever we are having. See 0 to 1 we are having 2 no amplitude. Here it is double the axis. 0 to 2 you will get 2. That's what expanded version. See, it is expanded as 0 to 2 and its amplitude is 2. This is absolutely used in mobile. And today's right, whatever the applications you are sending, you can't send all the things in the mobile to the other side. If you want to send signals, you are compressing image and expanding image. At the same time, or the receiver, right, after getting the image or your signals, you have to expand, right? Absolutely, these two are used now, right? So expand versions of x of t by factor 2. Now see, 0 to 2 you are getting 2 now. 2 to 4 you are getting double and you are getting the same amplitude. This is the compressions and expansions. Now expanded versions of x of t by a factor 2 times. Similarly, next one is time shifting operation. This is also very, very important operation. That x of t be a continuous time signals, then y of t is obtained by shifted versions of x of t. X of t minus t naught is called time shifted versions of x of t. These operations, right, for example, where t naught is nothing but time shift. Let us take one signal x of t, 0 to 2 its amplitude is 1, at 1 its amplitude is 1, this is x of t. Now let us say based on this shift, right side you will get delayed signals. If you shift this t naught left side, you will get advanced signals. Now see, for example, based on t naught value, for example, t naught is greater than 0, then signal is shifted to right side, right? That is called delayed signals. Now see, x of t minus 1, x of t signal is delayed by 1 second. Now it starts after 1 second. Right, that is what x of t minus 1. If t naught is greater than 0, see this, t naught is greater than 0 means positive values this side. Positive value means delayed signals. If it is t naught is less than 0, what will happen? For example, minus 1 t naught. Minus of minus is plus, then advanced signals you will get. That's what it is. See, if t naught is less than 0, then the signal is shifted to left side, reverse, left side. See now, this is shifted by 1 second this side. Actually, your signal ends at 2. Now see here, your signal ends at 2 here, 2. It is advanced by this side it will shift. That is what x of t plus 1. Now see, it is advanced by 1 second. It starts at minus 1. That is what, so now signal is advanced by 1 second. Signal is delayed by 1 second. Your original signal is this. Your original signal starts at 0. Right, based on that time shifting operations we are doing. This is also we will see as applications now. You cannot see, for example, if you transmit to the other side, who is at a distance. Earlier you have seen this. If you call to America, you will get delayed signals only. Right, after seconds it was meeting early. Now it is reduced now. Now still it is not exactly, you will not get x of t. Delay calculate and start. Right, adjusting all that. That's an R&D left. Right, you can all reduce the delay even today also. Now lastly, time reflections. Time reflections, what actually it is mirror image of x of t. For example, x of t is there, just mirror, reverse of it. For example, x of t be the continuous time signals, then y of t is nothing but x of minus t. Minus t is nothing but is the reflected versions of x of t. Whatever is there x of t, no, reflections image, reverse. For example, now see, 0 to 2 it is here. 0 to 2. Here it is 0 to minus 2. It is exactly exists this side. Then minus 1 to 0 it starts here. Here 0 to 1 it ends here. Exactly reflected image of reflected signal of x of t. That is the other property. Now Let me see. I hope I am clear all these three properties, which is very, very useful. Let me repeat quickly. One is right. These are the three operations: time scaling, time shifting, time folding. Now to the independent variable. Now first one is time scaling. Here y of t is, you will get scaled versions of t, x of a t. Based on a value, you will get two types. One is compressed signals, the other is expanded signals. Now that's what this is a signal compressed by 2. This is a signal expanded by 2. Only the time axis I am talking, time, this is, right, I am not talking this, right, that is dependent variable. We talked last session only. Then time shifting operation is take one signal x of t, then it is delayed by 1 second means right shift, then advanced by 1 second means left shift, right, that's all. Then time reflection is last one, x of t, if you say signals mirror image or reflections is exactly reverse. That's all. I hope I am clear. Next class, right, let us use all these dependent variable operations and independent variable operations, both operations, all these operations we'll use, and we'll solve one problem, one complex problem, so I'll show you. Then we'll plot finally the signals, right, output signals. I'll show you that. It is very, very interesting. Wait for that, right. Before that, let me say thank you very much for patience listening, and let me end up with one big beautiful quote which is given by none other than our Dr. APJ Abdul Kalam, my greatest teacher of all of us. What is that? If you do duty honestly, if you do any duty honestly with honestly, you need not have to salute anybody, right? If you pollute the duty, if you are not doing the duty, if you are only create problems to the duty, then you have to salute to everybody, right? Now you just choice is yours. Let us do all. They start doing the duties without supervisions, with great motivations. By saying these few words, right? Also here you means to the students only, students of any class, any discipline, right? Mainly, and to all of us also. Thank you.